you go to year 11 and 12, this is the second part of the working for the revision sheet on solving equations. These questions are a little bit more difficult than 1 to 3, so make sure you've got pen and paper ready to work through them as we go. Okay, so a classic how wide is the path problem. We've done a few of these in class already. A 6 metre by 4 metre rectangular garden is surrounded on 3 sides by a path of uniform width of x metres. So in this question, the variable x is the width of the path. So we don't have to start from defining the variable here. We're told that the area of the path is 12 metres. So A equals 12. A is the area, metres squared. So let's take a look at the length and the width of the whole rectangle. So along here we've got 6 metres here, and we've got x here, and we've got x here. So that's x plus 6, which is 2x plus 6. This dimension is x plus 4. See, I've got the x there, let's change colour, x here and 4 here. So the area is 12, but it's also equal to the length times the width minus the area of the garden. So we'll call the length that dimension and the width this dimension. So we've got 2x plus 6 times x plus 4 minus 24. So expanding out those brackets, we get 2x squared plus 6x plus 8x plus 24 minus 24, which is 2x squared plus 14x. Now we know that that area is 12, so we're solving this equation here. I think I've just got room to do it on one slide. 2x squared plus 14x minus 12 equals 0. Let's divide through by our common factor of 2. X squared plus 7x minus 6 is 0. Right, now I've got a very simple quadratic to solve. I'm going to do that up here. X equals 0. I'm looking for two numbers that give me minus 6 here and a plus 7 here. So actually I can't do that by factorising. Okay, so I have a bit of a look, but because I need a plus and a minus, there's no way that that's going to come out with integer solutions. So I need to do the quadratic formula to solve this problem. So we'll do a new slide. Right, we're looking to solve x squared plus 7x minus 6 is 0. It's in the correct form for the quadratic formula. A is 1, B is 7, and C is negative 6. So x will be negative b plus or minus the square root of the discriminant divided by 2a. So that works out to be negative 7 plus or minus b squared, 49 minus 4 times 1 times negative 6 divided by 2. Right, now that all works out to be negative 3.5 plus or minus 1/2 times the square root of 73. So I get two solutions here. I get x equals negative 7.772 or x equals 0.772. Both of those to 3 decimal places. Now we need to take a look because one of those solutions makes no sense at all. We are looking for the width of the path. So we must have x greater than 0. So the width is 0.772 metres or 77.2 centimetres. And you can check back in with the original question that works out, and it does. Okay, so your final answer there is the path width is 77.2 centimetres. Next question coming up. Okay, calculate the value of the discriminant of this equation here. So the discriminant is b squared minus 4ac. and in this case b is -5, a is 2, and c is -3. Really should have started with a, but never mind. So b squared minus 4ac is equal to 25 minus 4 times 2 times -3, which equals 25 plus 24, which is 49. Okay, now since that number is strictly positive, the equation has 2 real roots. But as well as that, we can go one step further. Because the discriminant is a perfect square, then we know that both the roots must be integers. So that's the first part of that question done. Now the next part looks at a related equation, 2x squared minus 5x plus p equals 0. So notice that up here we had a take away 3, and now we just have a general plus p. And we're asked, when will that equation have no real solutions? So you can think about what this question's getting at is that this is a specific value of p, right? So that might be our one here, and it's got 2 roots. So we're really asking, when will this equation be hanging in the air like this? So we're trying to find the values of p for which it won't cross or touch the x-axis. So we'll do that on the next slide. Right, so no real solutions. Just change pen colour. Green, no real solutions. Requires the discriminant to be negative. So we've got a is 2, b is -5, and c is now p. So b squared minus 4ac is equal to 25, -5 squared, minus 4 times 2 times p, which is 25 minus 8p, and we want to find when that's less than 0. So 25 is less than 8p, 25 over 8 is less than p. In other words, p is greater than 3 1/8. Now if you play around with this on your graphics calculator or in GeoGebra, you can see what's happening here is that once p gets over 3.125, we move from a situation like this to one where it's got no roots. If someone can remind me to show you that in class, I'll do that next week. Right, next question, a wordy one. One that looks really hard, so you need to take it a little bit slowly. Tracy competes in a duathlon comprising of running and cycling a total distance of 50 kilometres. It takes Tracy 3 hours and 15 minutes to complete the event. If she runs at an average speed of 8 kilometres an hour and she cycles at an average speed of 20 kilometres per hour, how far is the running leg of the event? So we're going to define x as the run distance. So if we work out what we know about x, we know the total distance is 50. So we can draw a picture like this. The bike distance is 50 minus x. Now we can think about the time taken, which we know is 3.15 hours, as the run distance divided by the run speed plus the bike distance divided by the bike speed. Now if you're having trouble thinking about that, imagine that the run distance is 16 kilometres. Okay, so suppose it's 16 kilometres, then the time taken for that will be 16 divided by 8, which is 2 hours. Now I'm leaving my time unit here as hours. It's tempting as soon as you see a problem with hours and minutes to convert that all into minutes. You can do that but then you have to convert your your speeds into kilometres per minute. So it's going to get very messy. So this question's quite straightforward if you just use the information in the form you've got it. So what I've got here is an equation of an algebraic fraction where I have to get a common denominator. So I'll do that on a new slide. Now I've made a big mistake. I'm hoping someone's picked it up. 3.15 is wrong, right? Because it's 3 hours and 15 minutes. So a very stupid thing to do, never mind. Fixing that up. Now 3.25 is equal to x over 8 plus 50 minus x over 20. Right, notice everyone that I put in my invisible brackets, so I avoid making a mistake there. 3.25 equals, right, I'm going to do a common denominator here. I'm not going to do 8 times 20 is 160, because I can do the lowest common multiple, which is just 40. So 8 watts of 40, 8 fives. So we times numerator and denominator by 5, so 5x. 20 times what gives me 40? 20 times 2. So it's 2 times 50 minus x. So now I get 3.25 equals 5x plus 100 minus 2x over 40. Cross multiplying that, we get 130 equals 3x plus 100. Look, the whole problem's collapsed into a really easy Year 9 linear equation. 30 equals 3x, x equals 10. Run is 10 kilometres, therefore bike is 40 kilometres. And we can check back in that that works. You can do that quite easily, just about do it in your head. If the bike is 40k, it's going to take 2 hours. And if the run is 10 kilometres, it's going to take 1¼ hours. So that all works out. Okay, last question. Show that this equation here has 2 real roots. So we've got a discriminant problem. Again, a is equal to k, b is equal to 2k plus 1, and c is equal to k plus 1. Right, it is time for the 80s, cheesy 80s music. So here you go. First email to send in and tell me who the singer is and what the song is gets chocolate fish when we're back at school.
Still don't know what I was waiting for, and my time was running wild in dead-end streets.
Okay, feel free to enlist the help of your parents if you can't figure that one out, because they probably can. Right, back to the discriminant. B squared minus 4ac is equal to 2k plus 1 squared minus 4k times k plus 1. Right, so b squared minus 4ac. So that works out to be 4k squared plus 4k plus 1 minus 4k squared minus 4k, which is equal to, lots of things are going to disappear, 1. Now 1 is greater than 0, so that means the equation has 2 real roots for any k, except for k equals 0, in which case this whole thing would just collapse. Alright, very last question on a new slide. Right, we need to give the roots of this equation. So x is equal to quadratic formula. Now we've already got the discriminant here. So x is equal to negative 2k plus 1 plus or minus the square root of 1 divided by 2k. So that equals negative 2k minus 1 plus 1 over 2k, or negative 2k minus 1 minus 1 over 2k. This works out to be negative 1, and this works out to be, let's see, negative 2k minus 2 over 2k. We can divide through by 2, so negative k minus 1 over k. Okay, that's all for now. Let me know if there are any problems, and I'll be back with some more revision videos soon.